Hello students, in this session we are going to learn about dead space. What is the understanding of dead space? So any space that is not going to contribute to your respiration or gas exchange, that is called a dead space. Let's understand dead space. When we breathe in air, that is normal tidal volume. The normal tidal volume is 500 ml per breath. Every time you breathe, you take in 500 ml of air. Out of this 500 ml of air, 150 ml stays back in the anatomical dead space. That is your trachea and bronchi. They are the conduction space. So 150 ml becomes anatomical dead space. Why it's called dead space? Because this air, there's no alveoli there in trachea and bronchi, so it cannot contribute to gas exchange. Respiration is not taking place there. That's why it becomes anatomical dead space. The remaining air moves inside to occupy your alveoli. The air that goes into the alveoli, this is going to take part in gas exchange, because on the surface of the alveoli only gas exchange takes place. So this air becomes alveolar space. Note, this is not called alveolar dead space. It's alveolar space. It's a good space because all the air that goes into the alveoli is going to take part in gas exchange. Then what is alveolar dead space? If there is any smoker, the smoke particles would have destroyed the alveoli. So in smokers, the smoke dust has destroyed this alveoli. So in this person, this alveoli is not functioning. So now, the air that goes into this alveoli is not going to take part in gas exchange because that alveoli is damaged. Now this air that goes into this damaged alveoli, this becomes alveolar dead space. Alveolar dead space. So who will have alveolar dead space? Smokers could have alveolar dead space, or any person where they have any alveolar disease, any damage to the alveoli. Then that alveoli which is not taking part in gas exchange, the damaged alveoli, this will contribute to alveolar dead space. So any normal person, alveolar dead space is 0. If you don't have any respiratory trouble, if all your alveoli are functioning, it means all the alveoli gas exchange is taking place. Therefore, alveolar dead space is 0. All my alveoli is functioning, so I will not have any alveolar dead space. But a smoker or any other alveolar disease patient, if their alveoli is not functioning, then they will have a value for alveolar dead space. Normal alveolar dead space is 0. What is total dead space? Total dead space is anatomical dead space plus alveolar dead space. You add both, this will give you total dead space. Let's further understand this anatomical dead space and total dead space. 2 examples we'll do. Let's take any normal person whose all the alveoli are functioning perfectly well. So in this person, the tidal volume 500 ml of air moves inside. Out of this 500 ml of air that moves inside, almost 150 ml stays back in the anatomical dead space. This 150 ml which occupies the trachea and bronchi. That's called anatomical dead space. 500 ml of air came inside, 150 ml stays back in the anatomical dead space. The remaining air moves into the alveoli. The remaining air which moves into the alveoli, this is going to take part in gas exchange. This is a normal person whose all the alveoli are functioning very well. So will he have any alveolar dead space? So he will not have any alveolar dead space. Why? Because all his alveoli are functioning. All the alveoli taking part in gas exchange. So his alveolar dead space is 0. He doesn't have any alveolar dead space. Now you calculate total dead space. What is total dead space? Anatomical dead space plus alveolar dead space. What is his alveolar dead space? 0. Because all his alveoli are functioning well, he doesn't have any value for alveolar dead space. It's 0. So you see that anatomical dead space is equal to total dead space. Why? Because his alveolar dead space is 0. So in any normal person whose all the alveoli are perfectly functioning well, anatomical dead space is equal to total dead space. Anatomical dead space is equal to total dead space. This is a normal person. Now let's take a smoker. Every time I say smoker, I should give this disclaimer. This is not to hurt anybody. So let's take any smoker or any person whose alveoli has been damaged. Now in this person, tidal volume 500 ml of air moves inside. Out of this 500 ml, 150 ml stays back in the anatomical dead space. The remaining air moves into the alveoli. The smoke dust, he's a smoker, no? The smoke dust particles, it has damaged his alveoli. Let's say this alveoli has been damaged by the smoke particles, or this a person with any alveolar disease or alveolar damage, this particular alveoli has been damaged. Now, the air that goes into this damaged alveoli cannot take part in gas exchange. So now this becomes alveolar dead space. Alveolar dead space. So he is having a value for alveolar dead space. So now let's calculate his total dead space. Total dead space is the sum of anatomical dead space plus alveolar dead space. We now see his total dead space is more than anatomical dead space. Why? Because he has a value for alveolar dead space. There are some alveoli which are not functioning. That is contributing to alveolar dead space. Since he has a value for this alveolar dead space, when you add both, total dead space becomes more than anatomical dead space. So in smokers or any alveolar disease patients, total dead space is more than anatomical dead space. The normal person, anatomical dead space equal to total dead space. But in smokers or any alveolar disease patients, total dead space is more than anatomical dead space. The other name for total dead space is physiological dead space. Physiological dead space. The other name for total dead space, physiological dead space. Now look at these statements. In any normal person without any lung disease, without any alveolar disease, anatomical dead space is equal to physiological dead space. Yes, the other name for total dead space only is physiological dead space. So anatomical dead space is equal to physiological dead space. But in smokers or any alveolar disease patients, physiological dead space is more than anatomical dead space. Physiological dead space is more than anatomical dead space. So normally anatomical dead space equal to physiological dead space. only in smokers or any alveolar disease, physiological dead space will be more than the anatomical dead space. See how I used to teach my college first year students. If you are a normal student, you will like anatomy, physiology both equally. So normal anatomical dead space is equal to physiological dead space. Only if you are abnormal, maybe like me, you will like physiology more than anatomy. Physiological dead space more than anatomical dead space, only in abnormal conditions. So this is about the physiological and anatomical dead space concept. How would you measure all this? The measurement of dead space, measurement of anatomical dead space. How will you measure anatomical dead space? This method is called single breath nitrogen method. Single breath nitrogen method, or that's called the Fowler's method. Fowler's method. How would you measure total dead space? Measurement of total dead space. This is called the Bohr equation. What is this Bohr equation? Vt into PaCO2 minus PeCO2 divided by PaCO2. This is equal to total dead space. We will discuss all the components of this Bohr equation. We'll discuss. We'll see how we are going to measure anatomical and total dead space. We'll discuss each of these methods. So to start with, the first one, single breath nitrogen method. What is the single breath nitrogen method? You ask the subject to take a breath of 100% oxygen. Then he is going to breathe out through a one-way tube. It has a one-way valve that's called the nitrometer. So he's going to breathe out through this nitrometer. A nitrometer would measure the levels of nitrogen in this air. So when he is breathing out like that, continuously you measure the nitrogen concentrations and the volume in the expired air. And you mark a graph, the exhaled volume of air and the corresponding nitrogen concentrations. So this shows 4 phases. Phase 1, phase 2, phase 3 and phase 4. There are 4 phases here. What does these indicate? The first phase indicates that the first phase of air that comes out, so when you take in air like this and you breathe out, the air that goes last will come out first. So when air goes inside, it goes into the trachea, bronchi and all the alveoli. When this air comes out, the air in the trachea and bronchi will come out first. So the first phase air is the air that is occupying your trachea and bronchi. Because that has gone in last, it will come out first. So the first phase of this graph indicates the air that is in your dead space, or that's the anatomical dead space. How much ever air came out in that first phase, see, this air will not have nitrogen in it because you have made the patient to breathe 100% oxygen. So this air in your trachea and bronchi will have only oxygen in it. So that's why the nitrogen concentration is very low in phase 1, the last phase, phase 1. So it's at the bottom, the line. So if you measure this phase 1, it will give you the anatomical dead space because that is the air which came out through this anatomical dead space. Now phase 2. Phase 2, the nitrogen content in the expired air slowly increases, because now this phase 2 is the air which is coming out from your little bit of dead space and little bit of the alveoli. So it's a mixture of gas. First phase only because of the dead space air. Then you have the dead space with little bit mixing of this alveolar air. That's why it is a mixture. So this is having little nitrogen in it. So nitrogen content slowly increases. So in phase 2, nitrogen content in the expired air increases because it's a mixture of dead space and alveolar air. Then phase 3. The third phase. Almost it is a plateau phase. So in this phase 3, now the air that is only in the alveoli is going to come out. Purely from the alveoli. Nitrogen content has almost reached a plateau. This is the alveolar air. So this indicates the alveolar air concentration. At the end of phase 3, there's an increase in the nitrogen concentration. So from here, the phase 4, nitrogen concentration is increasing. Nitrogen concentration is increasing because this is the air which comes from your upper alveoli. Initially, your lower alveoli will close. So in phase 3, lower alveoli are all closing. So that's the air that is coming from the lower alveoli. But slowly what happens when it goes to phase 4, after all the lower alveoli has closed, now upper alveoli are closing. In the upper alveoli, the alveoli itself is more distended. So the nitrogen content here is less diluted with oxygen. Therefore, upper alveoli, it will look like as though nitrogen content is more because it is less diluted with oxygen. So the nitrogen content appears to be very high. That is phase 4. So these are the different phases of this nitrogen method. So the first phase, if you are able to measure, that will give you how much is the anatomical dead space, because that is the air which came out from the anatomical dead space, your trachea and the bronchi. The other one, measurement of total dead space. So total dead space is measured by this Bohr equation. Let us write the Bohr equation. This is simply physics and calculations, that's all. So Bohr equation is total dead space is equal to tidal volume minus PeCO2 into tidal volume divided by PaCO2. This is the formula. So I'll just tell you how we derived this formula. The derivation of the Bohr equation based on few concepts. So what is tidal volume? Vt is tidal volume. So you leave that equation as of now. So we're going to discuss how we derive this equation now. So we'll come to this diagram. Tidal volume, Vt, means the air that you take inside during normal breathing. So that is tidal volume. So tidal volume will have all the following components. Some of this tidal volume would have occupied the anatomical dead space, and the remaining has gone into the alveoli. This is called the alveolar space, and if there are any damaged alveoli, then it would have occupied the alveolar dead space. Alveolar space is the one alveoli which is functioning. Alveolar dead space is the alveoli which is not functioning. So tidal volume would have occupied these three compartments. Some air in the trachea, bronchi, anatomical dead space, and some air into the alveolar space, and some air into your alveolar dead space also. If you have, you will have alveolar dead space also. So now a sum of all these three is the tidal volume. The tidal volume is equal to anatomical dead space plus alveolar dead space plus alveolar space plus the volume in the alveolar space. I've just added all the three, that's all. What is anatomical dead space plus alveolar dead space? Total dead space. So you add this both, that is nothing but total dead space. So instead of anatomical dead space plus alveolar dead space, I can write total dead space. So now the equation becomes tidal volume equals total dead space plus volume of alveolar space. From this, can I calculate total dead space? So we'll take total dead space to the other side. Total dead space is equal to tidal volume minus alveolar space. So I've just taken this alveolar space to the other side. So tidal volume minus alveolar space. Tidal volume, you can calculate tidal volume. Volume of alveolar space. How will you calculate volume of alveolar space? So now we'll see how to calculate this volume of alveolar space. So by spirometer, you can calculate this VT, tidal volume. Alveolar space, how will you calculate? So this method to calculate alveolar space. So how will you calculate? So now what you do, you ask the patient to breathe into a bag. So now this patient is going to breathe into a bag. Now air comes out and this is going to go into the bag. Now what are we doing? We are trying to calculate this alveolar space. When this patient is breathing into the bag, from the bag you can calculate PeCO2. PeCO2 means partial pressure of carbon dioxide in the expired air, because the expired air goes into the bag. So that will give you PeCO2. If you measure the volume of the bag, that will give you the volume of the bag. So now you know the PeCO2, partial pressure of carbon dioxide in the bag, in the expired air, and the volume of the bag also you can measure. Now applying Boyle's law. P1 V1 is equal to P2 V2. Because the air that was present in your respiratory tract, that only has gone into the bag. So the pressure into volume in your respiratory tract should be equal to pressure into volume in the bag. So applying this, what is the pressure into volume in the respiratory tract? In the respiratory tract, there are two components. You have anatomical dead space component, and inside you have the alveolar space component. So the air from the alveolar space and the air from the dead space, that only has gone into the bag. So now if you measure P into V of the dead space and P into V of the alveolar space, you add both, this should be equal to P into V of the bag, correct? P1 V1 is equal to P2 V2 means the air in the respiratory tract, which is made up of the dead space and your alveolar space, should be equal to the P into V of the bag. So we'll write this now. Partial pressure of carbon dioxide in the dead space. The top air is the dead space. So I'll put ds in the dead space into volume of this dead space. Volume of the dead space. Volume of dead space. Plus, now we'll do this for the alveolar space. Partial pressure of carbon dioxide in the alveolar space. Alveolar space, we'll put alveolar here, into volume of this alveolar space. This should be equal to P2V2. What is P2V2? Partial pressure of carbon dioxide in the bag. Bag is the expired air. So you can say partial pressure of carbon dioxide in the expired air into V. V is volume of air in the bag. What is that volume of air in the bag? Whatever air you have breathed out, that only has gone into the bag. So what is that volume of air that comes out during normal breathing? Tidal volume. So tidal volume only has gone into the bag. So this volume in the bag or the tidal volume, both are same. Because tidal volume only came out of your lungs, that only has gone into the bag. So instead of this, we can write volume in the bag or the tidal volume. What is the value of partial pressure of carbon dioxide in the dead space air? Dead space means your trachea and bronchi. You remember we learned partial pressure concepts? What is this air actually? The air that is present in your trachea and bronchi. So that is nothing but your inspired air. What is the value of inspired air partial pressure of carbon dioxide? 0.29. Or let's take it as 0. So plus or minus 0. So 0 into anything is going to be 0 only. So this part is going to become 0 because partial pressure of carbon dioxide in trachea and bronchi is less than 1. 0.29 only. 0.29. Or we'll take it as 0. So the whole value is negligible. It becomes almost 0. So we are going to leave this part which is 0. We'll take into consideration only the other part. So I'll further write this equation taking the top one as 0. So I'll take this to the other side and I'll write the same equation there. Partial pressure of alveolar CO2 into volume of alveolar space is equal to PeCO2 into volume in the bag or the tidal volume. So this same equation I have taken to the other side, I have written it there. Considering the other part as 0, we leave that and the remaining I have written it here. So from this, can I calculate volume of alveolar space? I'll keep only volume of alveolar space here. So we'll take this to the other side. So it becomes PeCO2 into tidal volume by partial pressure of carbon dioxide in the alveolar air. Now we have found out volume of alveolar space. Now what is the formula for tidal total dead space? Total dead space equals tidal volume minus volume of alveolar space. Now when you put this volume of alveolar space into this, now you get this equation as total dead space is equal to tidal volume minus PeCO2. Instead of volume of alveolar space, I am writing what is that volume? PeCO2 into tidal volume divided by PaCO2. Did you arrive at this equation now? We wrote the Bohr equation on top. See, we have arrived at this equation. Total dead space is equal to tidal volume minus PeCO2 into tidal volume by PaCO2. What is the value of PaCO2? Tidal volume as spirometry you will know. PeCO2 from the bag you can measure. And again tidal volume you know. What is the value for PaCO2? Partial pressure of carbon dioxide in the alveoli. Partial pressure of carbon dioxide in the alveoli and in the arterial blood, pulmonary capillary, both are same. How much is it? You remember 140 concept we learned? Yes. So it is 40 on the alveolar air and 40 on the pulmonary capillary. So it is same on the both sides. And when this pulmonary capillary goes into pulmonary vein, so there also partial pressure of carbon dioxide is 40. From the pulmonary vein into the left side of the heart and then into the aorta, in the systemic arteries, there also it is 40. So if you take a sample of arterial blood and you measure the partial pressure of carbon dioxide, it will tell you how much is the arterial partial pressure of carbon dioxide, which is same as the alveoli. What is the value of partial pressure of carbon dioxide in alveolar air? 40. What is the value of partial pressure of carbon dioxide in your arterial blood? 40. So for reference, please go through the videos on partial pressure concept. So you will understand that partial pressure of carbon dioxide in alveolar air is also 40. Systemic arteries is also 40. So you take a blood sample from the arteries, you measure the partial pressure of carbon dioxide. This will give you this value. So whenever you see PaCO2, it can be alveolar or arterial. Both are correct only because both the values are 40, same. So we can put that value 40 here. We can take a blood sample, measure that, you can put it here. So when you put all this, you will get how much is the total dead space. So this is the final formula for total dead space. That is called the Bohr equation. The derivation is little complicated, but make some efforts, try to just understand this. This is the Bohr equation. Let's try to answer this question. True or false? In any normal person without any respiratory disease, that means he is normal, the anatomical dead space is equal to physiological dead space. Anatomical dead space is equal to physiological dead space. Physiological dead space is otherwise total dead space. Is it correct? Normal student, you will like anatomy and physiology both equally well. So in any normal person without any respiratory disease, anatomical dead space is equal to total dead space because his alveolar dead space value is 0. So this statement is true. So that completes the learning of dead space concept. Thank you so much for watching. Please join us for the subsequent videos on respiratory physiology. Thank you.